let's just display it. And let's lock our display here so we always see that part. And let's just make our network a little bit bigger. First things first, we will do a switch to turn off that ball. I'm not a huge fan of it, so let's just find a switch for it where we can turn it off. Let's see where it's actually happening. So we can see here the axes. If you look at it, oh, sorry. Yeah, so this is the axes. This is where the axes are created. And then there's a style, so they scale down and they copy to the points. Here you go. So that's the axis. Oh, and the ball is actually here. It's called a joint geo for some reason. Here we go. And here we have a joint scale. If we look at it, yeah, it's a joint scale. So that's the ball, that's the joint scale. Then it's copied to the points, yeah. So we'll add a switch for it so you can turn it on and off, okay? And let's see how it works. So basically it's just copying stuff to the points and actually like remove all of them. So let's add a switch. Cool. And let's add a null. Null. And the null will be as a first input, so we just need to reorder it. So the null is first, and there are a couple points, and we will call this one hide ball. Oh no, show ball, because when it's 1, it will show it. Okay, so the show ball. Cool. So this one is done. Let's see how it works. When you select it, the balls are on, balls are off. Cool. Then we're gonna change. Let me show you now how does it look. Okay. So we're having our. No, we don't want to be in rig state. So we're having our rig visualizer, and we are. So now when we're scaling our hats, that doesn't look good. But as soon as we switch to GNOME, we start getting those cool axes, and they're always visible, so that's pretty cool. And let's add switch for it. So we'll go option bar and type properties, because we're gonna edit our HDA, and we will go to parameters and call it where is the checkbox? The toggle. Let's add toggle. Here you go, and let's move it. Let's move it maybe under show. Join style. Show parent to child. Maybe here, and let's call it show ball. Show ball. Cool. Apply. Accept, and we'll just copy. And we'll go here and do paste relative reference. Cool. So now if we go up, you can see how cool it is, because you can see how much view the balls abstract, especially if you have lots of joints here. You're like, what am I looking at, right? So now you can basically just turn the balls off, and you have this pretty cool just GNOME visualization, and you can scale them and you don't care. Now next we want to draw really nice joints here, so let's start working on that. Okay, so let's hide this guy and let's see where the drawing of the joints happen, and it's happening here. So the thing is, there's a tube here, you see, that's the tube. It's kind of in the middle between 1 and -1. Then is a white color always here, and then we just like make it much smaller. And okay, the joint scale, that's fine. Okay, so that's what it's copied, and it's copied all over. So that's that doesn't help us a lot, because also if you look, that's our joints here, right? And when we copy these guys, it's actually in the middle. We would like to have it starting from here and just going down to the joint. So I will tell you that there is actually code here which do the calculations. This one, you can see that's where those guys are placement. So that attribute wrangler is actually calculating where those guys will be placed and probably have a p-scale on it. And it actually does have a p-scale. Look at that. There is a p-scale here. So what's happening here in this code, I will just walk with you through it. We're getting points for the primitive. So we're going through every primitive, and a primitive is basically, you know, every bone, right? And in this case, primitive has 2 points. There's the start and the end. So we're getting position of, for that, you know, particular point, like a start point, we're getting position and the end. Then we're calculating difference between those 2 points. So you're kind of getting not kind of, you're getting a vector, which is pointing, you know, where is that, you know, that end part of the joint. And then we are adding the point in the middle of it. And that's what we don't want to do. So we're going to comment this one. And we're going to type int pt. We're going to add a point, but we're going to add it at start because we want to add at the beginning, right? So that was easy. Cool, right? Those all of guys shifted where they should. Now we want to fix the tube. Okay. Oh, sorry. Now we want to fix the tube because we want a tube to start where the point is, and that's because of the tube. If you look at the tube, we want it started from origin and goes to the 1. Okay, that's actually pretty easy to fix. And we go here, and now, so the center we will do in Z, we'll do 0.5, and the height of the tube will be 1. So the tube is unified, it's from, you know, 0, 1. Okay, we'll kind of change this radius a little bit, maybe to 0.7, because we'll be scaling a tube with a p-scale attribute. And let's say rows, I really like just 4 rows, like just like a kind of a bone, you know, drawing. I don't like this kind of like very pointy things. Yeah, that's much nicer. Cool. And also, if you want, it's you know, it's a very preference. Yeah, if you want to scale it in one direction, we just need to add the transform here. So that's the Y, that will be cool. That's a Z. So we can do it, for example, here we can do transform, and let's just flatten it a little bit. Okay, flatten, bone, flat, okay, and this is, let's say, a bone shape. You know, whatever you do, I always recommend to just, you know, like create the nice names in your HDA. So now in the X, we're just gonna, whoopsie, it didn't display it. So now in the X, we're just gonna flatten the bone just like this, just a little bit. So we're gonna have just a slightly better direction and see where we're going. Cool, and let's see how that looks now. That starts looking pretty good. You see, we're actually getting a bones. You know, starting from the points, if we display the point, that's the points, and we display the bones now, yeah, they start where they should, but you see that the length of it is not good enough. And if we look at the code, it's because of the p-scale, of course. So what's happening here, you can see here, we're calculating a difference. So what's happening is picking up the scale from a joint. That's not what we want to do, basically. We can leave it as it is, and we can just change that, and we will get the length of that vector, of that, because that difference is basically the vector from here to here. I mean, you know, vector is from a 0, but it's a vector in this direction, but it's a length of the bone. So we actually, that's why we need the length of the bone. So we do float p scale, and we do length, and we do diff, that vector here, which we found. and that's perfect, and let's hit the enter, and voila, it's a little bit smaller than we thought, and that's a little bit smaller. Okay, so what we need to do now is basically to go to a transform, and that's responsible for scaling our joints based on the joint scale. And what we need to do, we need to just scale it in X and Y, you will see, and not uniformly. So the Z stays where it is, so the Z will be always 1. And here, voila, so we're getting this this cool looking chain. And if we go here, yeah, okay. And the last thing what we can do is to make those bone links uniform. Currently you can see like the shorter bones have yeah, smaller, shorter bones have the bones smaller, and the bigger one has bones bigger in terms of radius. And sometimes it's that what you want. It's up to you how you basically set it up. You can add a switch for that. I personally prefer to have a bones of all the same size, but it's just a preference. We can always change it. So let's just add that change. And so what we need to do now, let's create so instead of using a p scale, because the p scale is a uniform scale, we will use a scale attribute. So let's do vector, and let's call it s, maybe scale. Just to keep it consistent. Let's do set, and we want to be the same in X and the same in Y, but just scale in the Z. And in the Z we use a scale, p scale, the value, it's just float. And we're gonna use a set point, but let's just copy all of it, and let's comment this one here, and let's just copy down here, and let's call it scale. So scale, it's a point attribute, and it's a vector. So that allows you to scale the whatever you copy on the points in whatever axis you want, and it's always taking over. So if there is a scale declare for a copy point, that will be scale values used. If there's a p scale and the scale will override the p scale. If there's only p scale, the p scale will be used. Scale, writing down the name of the vector. Scale, cool. And yeah, voila, look at this. So we're actually having here a really nice bone display. Look at this. So that's actually really cool. And I think the last thing which I would like to do is to close those caps, end caps. Yeah, here you go. And yeah, just let's close this one, and let's see how does it look if we go outside. This goes out, and let's show the parent to child. Yep, we actually are having a really cool really cool bones with the axes. Yeah, this actually looks much better than what we had before. Cool. And I think the last thing which I would like to do is to be able to change the color here. Currently it doesn't really work. It only works when you when you create some joints, I think. Yeah, you see, we need to fix that, and it's actually pretty easy to fix. So let's go type properties, and the color, let's just display label for link color. I think link color that's what we need. Oh, I didn't accept it. So the type properties, the link color, let's do label, apply, accept. Now I can click on the color and do copy parameter, and we can go inside. And I think if we do color here, color, right, select this one and do base relative reference. Okay, that's pretty cool. So let's go up, and we can just get rid of that white color, which was super annoying. Let's just grab here. Let's turn off that label because we don't need that. We just have it here. and we can just make it whatever colors we want, maybe a gray or maybe a little bit blue. Nah, the blue will be for sides, so maybe a little bit gray like this, why not? Okay, that looks pretty cool. And yeah, we're having actually a nice scale parameter here, and we can just shout it. And yeah, so yeah, that looks pretty cool. And at the end, you just need to go and save node type and match the current definition. And yeah, that's basically it for the rig visualizer.